Okay, so in this video we're going to take a look at complex numbers and quadratics in complex numbers where we don't have integer values. We're actually dealing with complex numbers, and what we are dealing with then is a quadratic, so we know that we can use the minus b formula. So in this scenario I'm going to get z is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So we know that from junior cycle, any quadratic that doesn't work out by our normal factorization processes, we can work that out by using the minus b formula. So in order to use this formula, what we're going to need to do is identify an a, a b and a c. So our a is always the coefficient, in other words the number in front of the z squared, the coefficient of the z squared. So in this scenario it's going to be 1. The next thing I need to find then is going to be the number in front of the z. So I'm going to colour that in here. So we're going to go and find that. Now that is minus 4 plus 2i. So what I'm going to fill in here actually to make it easier on myself is multiply that minus in. So I'm going to get minus 4 minus 2i. And then finally the plus c is always the constant. So the c is our constant value, which is 3 plus 6i. And we're going to fill that in for ourselves then. So 3 plus 6i. So we're going to fill all of this in then. So the minus comes from the formula, but then as well I'm going to be having minus coming from our b as well. So I'm going to be careful with that and put that in a bracket to make sure that I'm getting the easy steps right here in this question. So then I'm going to have the square root of b squared. So what I have for b is minus 4 minus 2i. So minus 4 minus 2i. Then that's going to be minus 4, which comes from the formula, multiplied by a multiplied by c. So multiplied by a is 1. Multiplied by c is 3 plus 6i. So that's nice and easy. Just filling into the formula. And then what we're going to do is divide that all then by 2 by a, which we now know 2a is 2 by 1. So that's what we get when we substitute into the formula. I haven't changed anything. All I've done is identify a, b, c and fill it into my formula. And what we do now then is we start to tidy it out as much as we can. So I'm going to say z is equal to minus by a minus actually gives us a plus. So that becomes plus 4 plus 2i plus or minus the square root of, we're going to have this squared. Now this squared, take your time with it. It's going to be the first one squared, which is 16. It's going to be twice the product. So the product is going to be minus 4 multiplied by 2i. That will give me, the minus by minus gives me a plus. And then the 4 by 2 is an 8i. So 4 by 2 is 8, by I is 8i. But it's twice the product. So it's going to be plus 16i. And then we're going to have minus 2i squared, which gives me positive 4i squared. Then I'm going to have minus, and then it's going to be 4 by 1, which is 4, by 3. So I'm going to get 12 there. And then I'm going to have minus 4 by 1, which is 4, by 6i, which is going to give me minus 24i. So this is what we have there, and don't forget all over 2 multiplied by 1, which we can just write as 2 for now. Right, the next step that I can do here actually is a minor change, and I would write it out as the minor change. Keep things simple, break things into small steps as you can, and pick up the marks where it's nice and easy. So I can replace that I squared. We know that I squared is actually minus 1. Right, we know that from complex numbers. It's one of the most important things from that chapter. So I squared is minus 1. So I'm going to fill in minus 1 there. What that allows me to do then is change the value of that plus 4 to a minus 4. So I'm going to move that down here. Just copy and paste it so we can speed up the calculation a little bit. All that allows me to do then is change minus 1 by 4 to minus 4. So I'm going to write that in. So that's what we have. And now what I'm going to do is I'm going to tidy this up as much as I can. So I get z is equal to 4 plus 2i, no change there, plus or minus the square root of, so plus or minus the square root of 16 plus 16i minus 4, that's going to be 12 if I combine those two together. 12 minus 12 then. All of those actually end up cancelling each other out, right? Because they'll all add up to 0. So that's what we get there. And then I have 16i minus 24. Now 16i minus 24 is going to give me minus 8i inside here. And then that's all over 2. Now we are used to that working out to be either a positive or negative number that we can deal with, an integer of some sort, right? So we know how to deal with negative numbers now. We know that that's where complex numbers come from, but we're not really sure yet how to deal with the scenario where we get the square root of minus 8i. What I do know about that solution is that square root of minus 8i, that would work out to be some sort of a complex number, right? So I know that's not going to be a nice integer, it's not going to be a nice natural number. So I actually know that the square root of minus 8i works out to be a complex number. So I'm going to write that. So the square root of minus 8i works out to be some complex number. And normally in maths, when we don't know what the value of something is, we'd let it equal to x. But in complex numbers, it's a little bit more complex, I suppose, than what we're used to dealing with. So there's two parts to that number. Remember, there is a real part, so I'm going to call the real part A, and I'm going to call the imaginary part BI. So there's two parts to complex numbers, the real and the imaginary. So I'm going to let the square root of minus 8i equal to A plus BI. And this is similar to some of the questions we were practicing before. What I can do here, my first step would be to get rid of that square root. And how I would do that is by squaring both sides. So what I'm going to do is square this side to get rid of the square root. And then I get A plus BI, all of that together squared. And this is something that we can do and we have worked on. So what I will get here is I will get A squared plus 2ABI plus, now be careful always here, B squared, I squared. And what I'm using there is the indice rules. If you think back, if you have two things in a bracket multiplied together and then you raise that to some power, both of those things get raised to that power. So just be careful with that. Both of them get raised to the power of 2. If I then tidy that out even more, so I'm going to have this scenario, A squared plus 2ABI plus B squared, and what we said we know about I squared is that that is minus 1. So that's minus 1. So I've just replaced I squared with minus 1 in that scenario. So that's what we have done there for ourselves. And then we're going to say that's equal to minus 8i. Tidying it up even more, I can actually say A squared minus B squared, putting my real terms together and my imaginary terms together there, and I'm going to get minus 8i. So I don't actually have a real number on this side. I could put in a 0 there saying that there's no real number. 0 is just a placeholder, and we can use that to our advantage here. What I'm going to look at now is that the fact that if I have an equation with complex numbers, I can only ever say that the real is equal to the real. So real is equal to real, and imaginary can only ever be equal to imaginary. So that can only be equal to this. And now I can set up two equations for myself. So I'm going to set those up here. I'm going to say then that 0 is equal to, because the real part is 0, is equal to A squared minus B squared. I can also say, and set up the equation, minus 8i is equal to 2ABI. So first thing I can see here is that I have two equations with two unknowns. And whenever you have two equations with two unknowns, or unknowns being A and B, I can do a simultaneous equation. Now, what we're going to do in this scenario, because it's a non-linear simultaneous equation, we can't just stack them up and take them away like we normally would. What we're doing in this scenario is we're actually looking at substitution. So I must first organize this such that I have a equals or b equals on its own. So I'm going to do that. So the first step here I'm going to do is divide by I, and if I do that I get minus 8 is equal to 2ab. I can then divide by 2, and if I do that I'll be left with ab is equal to minus 4. And then in this next step I could divide, say I'm going to divide by b in this next step, and then I'm going to have minus 4 all over b is equal to a. So I've just managed to get for myself what a is equal to in terms of b. And what I can do with that piece of information is, instead of a here, I can actually substitute in what I know it to be. So I have currently 0 is equal to a squared plus b squared. So what I can do there is I can substitute in then and say that minus 4 all over b is now a, and I'm just replacing that in the formula, and I'm going to do everything else as I normally would. So what I get out of that then is I get 0 is equal to, I'm going to have minus 4 squared, so square the top becomes 16, square the bottom becomes b squared, and then it's going to be minus b squared. So I'm trying to solve this equation here, so that I don't really like that fraction, so I'm going to try and get rid of it. And to undo a fraction, which is divide, I would have to multiply. So I'm going to multiply everything through by b squared, and what I'm going to get there then is I'm going to get 16, and I'm going to get minus b to the power of 4. So minus b to the power of 4 like that. Then I'm going to have here I can actually see that I've got the difference of two squares. So if I look more closely at that, I actually have 4 squared minus b to the power of 4 could actually be written as b squared squared. Okay, so that's a classic question for the difference of two squares from the algebra chapter. So do keep up with your revision in that, and it'll really help in all areas of maths, not just the algebra chapters. So that's what I've got there, and I know that the general rule for the difference of two squares is if you have a square number, take away another square number, that goes to a minus b, a plus b. So I can actually factorize that out to be, the first number that we have there is 4. So the 4 goes at the start, and then it's going to be 4 minus b, 4 plus b. So that's what I've got. And all of that equals 0, remember. So I'm just going to move this down a bit here. So that's what we've just broken it down into. That's what we managed to do using the minus b formula. And that again is equal to 0. Okay, so at this stage, what I can do is I'm going to delete this now. So we should see where that comes from, the difference of two squares. Looking at this now, I can see I've got two things multiplied together, because that's what the bracket means, multiply. If I have two things and they're multiplied together and they give me 0, that means that one of them must be 0. So I can only ever get 0 as an answer for multiplication if this one was 0 or if this one is equal to 0. So I'm going to write that out now. 4 minus b must have been equal to 0, or 4, now I've done something wrong there, 4 plus b is equal to 0. What I've done wrong is I've a classic mistake, so it's a good mistake to make. I've forgotten to take my b squared, so that should all be b squared. So it is a common mistake to make that we forget the squared. So do make sure that you keep track of that. It's an easy mistake to make, so just make sure we keep track of it. B squared, because it's b squared squared. Alright, so at this point then, what we're going to be able to do is say that, okay, I'm going to say minus b squared is equal to minus 4, and here I'm going to say b squared is equal to minus 4. So divide everything by minus 1 or multiply by minus 1, whichever way you want to think about it. On this side, we're still going to have b squared is equal to minus 4. Now, when I initially put together that complex number a plus bi, one thing that we must note is that those have to be real numbers themselves. The a and the b have to be real numbers themselves for that to work. So I can't have this, because if I was to continue on to the next step there, I would get b is equal to the square root of minus 4, which we now know is not a real number, it's a complex number, so that's gone. So then I have b squared on this side does work out, that doesn't, so we can cancel it. Even before that stage, I can see that that needs to go, so I can get rid of that. So b squared is equal to 4, which means that b is equal to the square root of 4. And there's actually two solutions to that. We could have plus 2 or minus 2. So now that I have b, I can figure out what a is. So I go right back up here, and there was two options there. We had plus 2 and we had minus 2. Okay, so we're going to fill in both of those scenarios. And I'm just going to move this slightly over so we've got plenty of room to write this out. So I'm going to have my formula, which is a is equal to minus 4 all over b. So I've got it on this side, and I've also got it on the other side here. And we're going to be taking it for when b was plus 2. So we're going to have when b was plus 2. So we have a is equal to minus 4 all over positive 2. And if we work that one out, we're going to get that a is equal to minus 4 divided by 2 is minus 2. On this side, we're going to get a is equal to minus 4 divided by minus 2. That's the option we were looking at in this scenario. And so we get minus 4 divided by minus 2. That works out to be a positive 2. So what we have here is we have our a and our b for the two complex numbers that we were trying to find. So we have, remember, I said at the beginning that a plus bi was what we were trying to find. And a plus bi now in each scenario is different, but we've got minus 2 for a on this side, and that happened when b was equal to plus 2, so plus 2i. And the other one that I have is I'm going to have a, which is 2, and I'm going to have plus bi. b in this scenario, remember, was minus 2, so I've got minus 2i. Now what I can actually see is that these two are really, really close in value. What I could actually say is, well, I'm going to divide by minus here, and what I'm going to get is 2 minus 2i. And in this scenario, I'm going to get 2 minus 2i. So I basically have the plus version of it and the minus version of it. So I could say that here, a plus bi is equal to the plus version of 2 minus 2i, or the minus version of 2 minus 2i. It's just a neater way of writing it and taking both values at once, because that was really important at the very beginning of what we were trying to find. If we think back to why we were doing this at all, we did that because we said the square root of minus 8i is not something that we can find easily in our calculators. It's not something we can do in our heads. It's not going to be a nice solution. I do know, however, it's going to be a complex number, and I can write that as a plus bi. So we now know that the solution to all of this in the end, that the square root of minus 8i, we've found that out. We've actually managed to work it out. It just took extra effort to do that because it was involving a simultaneous equation. But I now know that the square root of minus 8i is actually equal to plus or minus 2 minus 2i. And why is that important and why is it useful? If we go right back up, we can now substitute what we just found out to be the solution of the square root of minus 8i back into this up here. So I'm going to write it out again down here. This is what we have, and remember, I now know then that I have this. So I'm going to replace, instead of writing all of this, I'm going to replace every piece of this with what I now know to be. It's plus or minus 2 minus 2i. So it was a little bit of extra work. So you can have a complex number inside in the square root. We just have to do a little bit of work around that to find out what the value of it is. So it takes a bit of time. So do just take your time with it, go slow. And then we have two scenarios here. We have the plus scenario and we have the minus scenario. And what we have is 4 plus 2i. So we have z is equal to 4 plus 2i plus 2 minus 2i. So plus 2 minus 2i all over 2. So we have that scenario, that is an option. Or we have z is equal to 4 minus 2i minus 2 minus 2i. And I've put that in a bracket because, of course, that minus is going to change everything for us. So we're going to then have z is equal to, if I tidy all of that out, I'm going to have 4 plus 2 is 6. 2i minus 2i goes to 0. So we've got nothing there. And it's 6 all over 2, which is a nice real number, which is 3. On this side, we're going to have 4 minus 2. So I'm going to get 2. And then I'm going to have minus 2. And then that's going to be... sorry, that's a plus. I wrote that wrong, so I was wondering why we were getting the same scenario. So this is plus from the formula there. So just take your time. Don't make those mistakes like I've made. And then we're going to have 2 when that happens. 4 minus 2, and then it's plus 2i minus minus 2i. So minus minus becomes a plus. 2i plus 2i is plus 4i. And remember, I've said a few times that, well, this is a real part and an imaginary part, and we have to write them as a real and an imaginary part separate, and we get 4 all over 4i all over 2 becomes 2i, and that 2 all over 2 became 1. And there we have our 2 solutions to that question. So a little bit of extra work to do to find out what the solution to the square root of minus 8i was. But we've done those questions before. We did them in the previous few pages where we spent time looking at real equals real, imaginary equals imaginary, and solving some complex equations. So do look over those last few pages, and don't forget that you can use, instead of x, the unknown a plus bi.